Okay, Algebra 1 fans, our topic for today, we're going to start Unit 6, Notes 6-1, Solve Systems of Equations by Graphing. After this lesson, students should be able to solve systems of linear equations by graphing them and finding the intersection of the lines. So before we start, let me give you your joke of the day. To whoever stole my Microsoft Office, I will find you. You have my word. Microsoft Word, have my word. Okay, so we're going to look at some examples where we graph the following lines and find their intersection. So we've got two equations here, y equals mx plus b. So these are both linear equations. The brackets that we're using here, you'll see this sometimes for what's called a system of equations. And we'll talk about that in a moment, what that means. So let's go ahead and graph the two lines. Y equals 1/2 x plus 1. The y-intercept is positive 1, so I'll put a point on the y-axis. The slope is 1/2. So from here we're going to rise 1, run 2. Now what I'm going to do that's a little bit different is I'm going to do this again. Rise 1, run 2, rise 1, run 2. And you'll see why in a moment. I'm also going to go down. So instead of going up 1 and right 2, I could go down 1 and left 2, down 1, left 2, down 1, left 2. So you see all the points are on the same line. So I can draw the line, connect the dots. Okay, now the second line here, I'm going to put a 1 in front of x. -1 is the y-intercept. So here's -1 on the y-axis. And the slope here is 1/1. So I'm going to rise 1, run 1, rise 1, run 1. And I keep going, and what happens, notice that I have the same point twice. The same point is on both lines. So if I draw this, we can see that the two lines intersect right there. And the coordinates of that point are 4, 3. All right, now, what that means, 4 is my x value and 3 is my y value. Let's say that I take the number 4 and I substitute it into the first equation, y equals 1/2 x plus 1. So if I do 1/2 times 4 and then add 1, we get 2 plus 1, which is 3. So when I substitute 4 for x, I get 3 for y, which is exactly what I have here. If I take the second equation, if I do x minus 1, if x is 4, I do 4 minus 1, which is, again, 3. This ordered pair makes both equations true. So in other words, 4, 3 is what we call the solution to both equations. That is the answer to both. Visually, what does that look like? Well, it's where the two lines cross. So it's the intersection point. So if we have more than one equation, we can actually solve these by graphing and finding where they cross. You can also solve these algebraically, and this is something we'll get into more in the next lesson, but let's say that I take 1/2 x plus 1, that's equal to y, but then 1x minus 1 is also equal to y. These two expressions are equal to the same thing, so what I'm going to do on the side here is I'm going to write them equal to each other. If they both, this equals y and this equals y, then that means they have to be the same. Now to solve it here, I would go minus 1/2 x on both sides, and then 1 minus 1/2 is 1/2. I'd go plus 1, and we would get 2 equals 1/2 x, and then to solve that, we'd multiply both sides by 2, and we get 4 is equal to x. Well, there we go. There's the 4. And if I wanted to find the y value, I would plug it back in here and I'd get 3. So I can solve these algebraically, but for today we're going to solve it by graphing and finding the intersection point. So the intersection point is the same thing as the solution. So let's take number 2. And we'll see again if we can find where the lines cross, where they intersect. The y-intercept is at 2. The slope is negative 3 over 1, so that is down 3, right 1. Or we could go up 3, left 1. And it puts you on the same line. So there's the first line. 1/2 x minus 5. So minus 5 is the y-intercept. And then the slope is rise 1 and run 2. Oh, there's the intersection. So my solution is 2, negative 4. And again, these are the values for x and y that make both equations true. In number 3, to graph the top line here, first I need to solve it for y. I'm gonna get it into y equals mx plus b. So to do that, I would go minus 2x, and we get y equals, I'll put the negative 2x first, minus 4. We're not allowed to combine those. But now we can graph. Negative 4 is the y-intercept. And now the slope is negative 2 over 1. So down 2, right 1, or up 2, left 1. I don't know how far I need to take this, so I'm just going to use the whole graph. And then the second equation, or I'll use green here, y equals negative 3/2 x minus 3. So negative 3 is the y-intercept. The slope is, I'm going to write that as negative 3 over 2. So I can go down 3 and right 2. That's close, but not exact. Or I can go up 3, left 2. There it is. That's not a very good line. But you see the intersection, and that is negative 2, 0. And again, if you wanted to check this, you could take negative 2 for x and 0 for y, and if I plug those in, I would do 2 times negative 2 plus 0, negative 4 plus 0 equals negative 4. So the top equation checks. In the bottom equation, negative 3/2 times x, negative 2, that's 3. 3 minus 3 is the y value, which is 0. That checks. All right, and then the last one here. Again, this is in the wrong format. 3x minus 4y is equal to negative 4. So let's solve it for y. We'll go minus 3x. Now that leaves us, careful, that's negative 4y equals negative 3x minus 4. And then we divide everything by negative 4. And we get y equals, this will be positive 3/4 x plus 1. So the y-intercept is 1. And the slope is 3 over 4. 4. Or I could go down 3, left 4. And then the second equation is y equals 3/4 x minus 2. So the y-intercept is at negative 2. Again, the slope is 3 over 4. 1, 2, 3, up. 1, 2, 3, 4 to the right. Or down 3, left 4. And what happens here, well, these two lines are what we call parallel. And the problem with parallel lines is that they're moving in the same direction, in the same way. These two lines are never going to cross. So it's not that at some point they would cross off the graph. They're never going to cross. So what we say here is there's no intersection. In terms of an answer, we would say there's no solution. And there's a symbol for that. It's a 0 with a slash through it. So the answer is that there is no solution if the lines never cross. Okay, so go ahead and flip it over, and we'll describe our situations here. Whoops. So in section 2, System of equations, types of solutions. What it means to be a system's like a group of equations that's two or more equations with two or more variables. So what's happening is that instead of just solving for x, now we have x and y. So now we have more than one variable that we're trying to figure out. Now if we're graphing these to solve, there's really three situations that can occur. Most of the time, the two lines, when we graph them, will cross in one place. So we would say that has one solution, one ordered pair. The vocabulary, we call that a consistent and independent system of equations. Now I'm going to skip the middle one. It's possible, like we just saw, that we have parallel lines. That is called an inconsistent system of equations, and there's no solution to that because they don't cross, they don't intersect. The solutions are where the intersection occurs. And then the third possibility is that we graph the same line twice, that we actually get the same line. So I'll put it in blue and red. So what if the equations are identical to each other? Well, where would they intersect? Where do they touch each other? It would be every single place on the line. So what would happen there? That would have infinite solutions. Every possible value for x would be an answer to that, and we would call that system of equations consistent but dependent. All right, and so we have one more question here, and this is a word problem, so let's take a look. Number 5. Suppose x represents the number of years since 2012, and y represents the number of units sold. So x is years, and then y is the units sold. Then the number of tablets sold each year since 2012 in millions can be modeled by the equation. So now we have an equation, y equals 12.5x plus 9. The number of laptops sold each year since 2012 in millions can be modeled by the equation y equals negative 9.1x plus 78.8. You don't need that last decimal. So we have, this is for the number of tablets, and this is for the number of laptops. Use Desmos to find the point of intersection. All right, Desmos is an online site. You could graph it by hand. You could use a graphing calculator. What we're looking for, okay, I'll show you on the graphing calculator. If I graph both of those equations, okay, I graph them, notice that they cross here. What I want to find is the intersection point. Now you can do this on Desmos. You can also do this with the graphing calculator. I'm going to do this algebraically. Okay, so I'm going to come down here. To find the intersection point, what I do is I take the two expressions and I make them equal to each other because they're both equal to y. They're both equal to y, so that means they have to be equal to each other. So what I'll do is I'll move the 9.1, the negative 9.1x by adding it. So I'm going to move the x to the left. That means I'll move the constant, 10.9, to the right by subtracting. And so that gives us, that would be 21.6x equals, that would be 67.9. Then we would divide by 21.6, and we get x is equal to 3.14. Okay, now what's important is to understand what that represents. So 3.14, x represents the number of years since 2012. So x, this is years, this is time, since 2012. Now, so that is the time. For part B, it says, in what year did tablet sales surpass laptop sales? So if I look at my picture again, we have tablet sales is here, And then laptop sales had the negative slope, that's here. And notice at the beginning, this is the time in years since 2012, the laptop sales were above the tablet sales until we got to this point. After this point, the tablet sales are now above, they have a higher Y value than the laptop sales. Okay, so how long did it take for that to happen? It took 3.14 years since 2012. So in other words, in what year did the tablet sales surpass? I would take 2012 plus 3 basically, and that would be the year 2015. Okay, so not on January 1st, it was a little bit further, but sometime in the year 2015 is when that happened. Now the other thing, though, if we want the point of intersection, we also need to find the Y value. So here's the X, what I need is the Y. Now to get that, if I'm doing it algebraically, I know that X is 3.14. I'm going to take one of my equations, I'll take this one, and I'm going to substitute 3.14 for X, and then I'm going to work it out. So 12.5 times this plus 10.9. I'll use my calculator. 12.5 times 3.14 plus 10.9 equals, so about 50.15. Now the Y value represents the number of units sold, and it's in millions. Okay, so in the year 2015, in 3.14 years, that's where the sales will be equal to each other, and the number of sales would be 50.115, and that's million. Okay, so we solved it algebraically, but again, if I was looking here, if I find what's called the intersection point, 3.14, 50.2, that's where they cross. So this is the time, and this is the millions that were sold. And that is the end of the notes.